Okay, welcome back. This is our first official lesson on radical expressions, and I am assuming that you guys have watched the introductory snow day videos coming into this lesson, but if you have not, you can probably still follow this lesson regardless, but this is where we're going to really investigate the foundations of radical expressions. Now, remember that radical expressions refer to laws of exponents. Go ahead and write this, laws of exponents, and remember that laws of exponents refer to what operation? Hopefully you say multiplication. Okay, so we're counting the number of times that we multiplied. So laws of exponents, counting the number of times that we multiplied. So if I write x squared multiplied by x to the third, if the bases match, what do we do with the exponents? We add them. This is 2 plus 3 is x to the fifth power. And if I write x to the fifth divided by x squared, when we divide and the bases match, x matches x, we subtract the exponents, we get x to the third. If I write x squared to the third power, when we have power of power, what do we do with the exponents? We multiply, we get x to the sixth. So we have addition of exponents, subtraction of exponents, multiplication of exponents. What's missing? What's missing is the division of exponents. So the division of exponents is where we come into radical expressions. So if you want to write here, radical expressions refer to what? Division of exponents. If you want to think of it that way, radical expressions of the division of exponents. We have fancy division symbol. Okay, so we're looking at the division. So we have x to the 18th, and we're going to say cube root of x to the 18th. In elementary school, you guys learned that 6 divided by 2 is 3. This is division of big numbers called the base. We have a big number 6 and a big number 2. Dividing 6 divided by 2 gives 3. This was elementary school division. Now we have high school division, fancy division. We're not dividing big numbers. We're dividing very small numbers called the exponents. So this is what? X to the 18 divided by 3. We write it like this. X to the 18 divided by 3 equals what? X to the 6th. And now, quickly some introductory information with radicals. Underneath this symbol is called the radicand. And this little number is called the index. Okay, so our index is the number that sits here. If I write square root, cubed root, fourth root, fifth root, the index is 5, the index is 4, the index is 3. What is the unwritten index? On square root, what is the unwritten index? So I'll ask this question on the test. What is the index of the square root? If the index is unwritten, we assume that the index is a 2. Do we ever write the 2? Do we ever write the 2? No. So if the number on a square root, the index is unwritten and it's assumed to be 2. This means that we're dividing by 5 down here, we're dividing by 4, we're dividing by 3, and on the square root, we are dividing the exponents by 2. Now, the foundations of radicals start with this. So if I write 2 times 2 equals 4, negative 2 times negative 2 equals 4. Okay, when we multiply a number by itself, what type of number do we get? 2 times 2 gives a positive 4. Negative 2 times negative 2 gives what? A positive 4. So when we multiply a number by itself, we get a positive number. Now the question is, what is the square root of 4? And I ask my students this every year. And several of them raise their hand when I ask, how many of you out there have heard that the square root of 4 asks the question, well, it does ask the question, what number multiplies by itself to give 4? What number multiplies by itself to give 4? Hopefully you are arguing, well, 2 multiplies by itself to give 4. What else multiplies by itself to give 4? Negative 2. So if you've ever heard this, the square root of 4, what number multiplies by itself to give 4? If you've heard that this is positive 2 or negative 2, we write this as plus or minus 2. It means positive 2 or negative 2. This is wrong. Okay, this is not correct. Let me say it very clearly. This is not correct. Why? Because if we define the square root of 4 to be plus or minus 2, then the square root is not a function. And that's bad. Okay, not a function if we define it to be plus or minus 2. What am I talking about? Okay, the whole point of this class is to study function. And first, let me say this. How many outputs do we have on the board? Well, you're saying that the square root of 4 is 2. On Tuesday, the square root of 4 is 2, and on Friday, the square root of 4 is negative 2. How many outputs do you see on the board? You see 2 different outputs. A function only has one output. So if the square root has 2 different outputs, then it is not a function. And if the square root is not a function, it has no application out there in the real world. Why are we learning this stuff? If you ever go into a math-related career, This stuff is used to solve real-world problems out there. So the question is, what do we do with this issue? Okay, it's not a function. Let me explain it like this. Okay, a function is a machine. We talked about this. Okay, so if I say a calculator is a machine, that means that the calculator is the function. So I say here, take this function, the calculator, and on Tuesday I want you to enter in the square root of 4. You enter in the square root of 4 on the calculator. On Tuesday it gives you the answer positive 2. Now on Friday I give you the same calculator and I say I want you to enter in the square root of 4. And on Friday you enter in square root of 4 and it gives you negative 2. Okay, is this machine useful? No, it's not. Let me make it even more clear. On Tuesday, I say here, into this machine, I want you to enter in 2 plus 3. You enter in 2 plus 3, it gives you an answer of 5. Okay, that's correct. And on Friday, I give you the same machine, and I say enter in 2 plus 3. You enter in 2 plus 3, and it gives you an answer of 17. Okay, so is this useful? No. The calculator is not useful unless it gives how many outputs for any input. It only gives you one output. So if you enter in 2 plus 3, what is the only output that you should see? You should only see one output, and that's the output 5. 2 plus 3 only has one output, and that output is 5. And if you entered it into the calculator on Tuesday, it will give you 5. If you enter it into the calculator on Friday, it will still give you 5. Okay, so a function is only useful if it has how many outputs? One output. Now, so what did the Society of Mathematicians decide to do with this? This is, okay, you remember those guys earlier this year? I told you they got together in a group. 0 factorial is equal to 1. Why is this the case? Because a group of mathematicians got together and said, okay, 0 factorial is 1. We call this a definition. Okay, they did this with several things, not just 0 factorial equals 1. This is because a bunch of guys got together and decided to do this. Why? So that it works. Okay, this is a man-made symbol. We want it to work. We want this to have one output. So they chose to ignore one of these two cases. And if you had to guess, which case did they ignore? Do you think they ignored the positive case or the negative case? Hopefully you can decipher that they probably chose to delete which case. They probably chose to delete the negative case, and that's correct. They deleted the negative case out. They chose to ignore the negative case. So we're just saying that the square root of 4 is not plus or minus 2. The square root of 4 is just what? Just 2. So now 5 times 5 times 5 is 25. Negative 5 times negative 5 is 25. So if I ask you, what is the square root of 25? Okay, again, what output did they choose to ignore? If I'm asking the question, what number multiplies by itself to give 25? Which output is, or which case is ignored? We say that the negative case is ignored. And how many outputs does this have? This just has one output. And what does this make it? Now, since it has one output, and we say our output is just what? Positive 5. Not plus or minus 5, just 5. What does this make this? The square root is now what? This is a function because it has one output. This is what? This is a function because it has one output. However, this causes us problems. So I'm going to show you guys how this causes us problems. So let's start with this. I need you to write this on your paper, that the square root of a positive number. So for instance, the square root of 4 is a positive number. 4 is equal to a positive number. So if I say the square root of a positive number, so for instance, if you say the square root of 4 could be argued, what number multiplies by itself to give 4? We could say plus or minus 2 arguably, but which case is ignored? We ignore which case? We ignore the negative case, and we say that this is just positive 2. So could you argue that the square root of a positive number is positive or negative? Yes, you could argue this, but this is wrong. It's cross out negative and say that the square root of a positive number is just a positive number. Now, let's look at something out in left. We're out in left field now, so this is not even related. This is completely different, So if I ask you, what is the square root of negative 4? What number multiplies by itself to give negative 4? Well, 2 times 2 is 4. Negative 2 times negative 2 is 4. This is positive 4. This is positive 4. When we multiply a number by itself, what does it give? It gives a positive number. Multiply a number by itself, what does it give? A positive number. So if I ask you, what is the square root of negative 4? What number multiplies by itself to give negative 4? There is no such number. Or at this point, we're going to say that there is no number. We're going to study this in this class called, let's just call this for now, non-real. This makes no sense. What number multiplies by itself to give negative 4? Right now you say what? There is no such number. Don't write no solution. I want you guys to write non-real. Okay, so we're looking at the square root of a negative number. Square root of a negative number makes no sense. So we're going to say that this is what? Not equal to anything. We're just going to say what? Non-real. And in a couple days, we are going to investigate this called our imagination. We're going to be investigating things that exist only in our mind. Now, kind of weird stuff. Now let's look at cubed root. So if I write this, 2 times 2 times 2 equals 8. Negative 2 times negative 2 times negative 2 equals what? Negative 8. What if I ask you the cubed root of positive 8? What number multiplies by itself 3 times, because our index is 3, what number multiplies by itself 3 times to give 8? Just 2. How many outputs do we have? We just have what? One output. Is this a function? Yes, because how many outputs do we have? Just one output. What is the cubed root of what? Negative 8. What is the cubed root of negative 8? Or what number multiplies by itself 3 times to give negative 8? This is negative 2. So, do we get one output for each case, both the positive radicand and the negative radicand? Yes. So this is a function, and it's very nice. So odd index. Notice up here, what was our index? Our index was an unwritten 2. We say that the index was what? Index was even. Down here, the index is odd. Okay, so this is really the key. Looking at cubed root. Cubed root of a positive number, for instance, cubed root of positive 8 is what? Positive 2, so the cubed root of a positive number is positive. And the cubed root of a negative number, cubed root of negative 8 is a negative number, negative 2. So cubed root of a negative is negative. So really quickly, one more time. Let's go through all 4 cases. Now, if I write 5 times 5 is 25, negative 5 times negative 5 is 25. If I ask you what is the square root of 25, can we argue all day that this is plus or minus 5, or what number multiplies by itself to give 25? You could say positive 5 or what? Negative 5. However, if we have 2 different outputs, is this a function? No. So which case is ignored? The negative case is ignored, and we say that the output is just what? Just 5. Okay, so this creates, or this allows, we call this now, this is a function now, because it only has one output. If I ask you, what is the square root of negative 25? What number multiplies by itself to give negative 25? This is a positive 25, this is a positive 25. There is no such number, so we say what? Non-real. These rules, positive, positive, and negative non-real, positive, positive, negative non-real, also apply to what? Any root that has an even index. So 4th root, 6th root, 8th root, etc., etc., etc. So this applies, these rules apply to what? An even index. Again, I'm referring to the number that sits here. This little number that sits here. So on the square root, the index is 2, which is even. And on the 4th root, we have a 4, we have a 6, we have an 8. These rules are for even index. If I write the cubed root of 27, remember that 3 times 3 times 3 is 27. Negative 3 times negative 3 times negative 3 is negative 27. So if I ask the cubed root of 27, I'm asking the question, what number multiplies by itself 3 times to give 27? This is just 3. And if I ask the cubed root of negative 27, what number multiplies by itself 3 times to give negative 27? This is negative 3. Do we have one output and one output for any given input? We have the input positive 27. We have an output of positive 3. We have an input of negative 27. We have an output of negative 3. Yes, we have one output, one output. This is also a function because we have one output. And the rule for positive, positive, or negative, negative, not only refers to cubed root, but it refers to any index that is odd. So this rule of positive, positive, negative, negative refers to any odd index, 5th root, 7th root, 9th root, etc., etc., etc. So the index is 9, index is 7, index is 5, index is 3. These are the rules that apply. So you can really say this. If the index is even, positive, positive. If the index is even, negative, non-real. If the index is positive, if the index is odd, positive, positive. If the index is odd, negative, negative. Okay, so those are our rules. Now, and we're going to talk more about this as time goes on. So If this is confusing you at this point, just bear with me. The problems are kind of easy, so let's go ahead and just dive into what are we supposed to do for this homework. How do we get the problems done? I just need you guys to start to understand this is not easy to digest, okay? So I'm going to show you guys a lesson that's very difficult to understand. However, the more you see this, the more you're going to start to go, oh, okay, I kind of see a little bit about what's going on here. Radicals are difficult. Okay, now looking at number 1 in the book. We're on page 400. No, I'm sorry. I'm on the wrong page. Page 434. We're looking at number 22 and number 34. Okay, so first number 22. We're looking at the 6th root of d to the 24th. Let me write it bigger so you guys can see it. 6th root of d to the 24th, x to the 36th. And on number 34, we're looking at the 8th root of x to the 16th, y to the 8th. Now, remember that radicals refer to the operation of what? Operation of multiplication. What operation do you see between the d to the 24th and the x to the 36th? Hopefully you say multiplication, multiplication. So we can simply divide our exponents. Remember, we are dividing exponents, so we're going to take 24, right? This is d to the 24 divided by what? Divided by 6. This is x to the what? Take the little number 36 and divide by 6. This is 36 divided by 6, which results in what? D to the 24 divided by 6 is 4. 36 divided by 6 is 6. So we get x to the 6th, d to the 4th. Okay, now, here we're dividing the exponents by what? Dividing the exponents by 8. So we get x to the 16 divided by 8 and y to the 8 divided by 8. 16 divided by 8 is 2. 8 divided by 8 is 1, so we get y to the 1st. And if you say these are the final answers, one of them is incorrect. Okay, so this second answer is incorrect. The first answer is correct. Now, let's look. Here we had what? Even number divided by even index. So what do you see here? You see even divided by even gave what? Even. Even divided by even gave what? Even. We're looking for even divided by even equals odd gives absolute value. Let's talk about this for a minute. And I'm going to explain this in the next lesson. I'm not going to explain it in this lesson, but I'm just going to introduce the idea. So even divided by even gives odd is what we're looking for. What do we have here? Even divided by even gives even. We're good. Even divided by even gives even. We're good. We're looking for what? Even divided by even gives odd. Now, what do we have here? Even divided by even. 16 is even. 8 is even. Even divided by even gives even. We're good. What do we have here? Even 8 divided by an even 8. Even divided by even gives what? An odd number 1. What happens when we have even divided by even giving an odd 1? We put absolute value. So just put absolute value around your y. What is this all about? Okay, this goes back to, and I'm not going to teach this in this lesson, but I'm just going to tell you, this absolute value symbol is to guarantee, remember the absolute value of 5 is what? 5, and the absolute value of negative 5 is what? Positive 5. What does absolute value create? Absolute value creates or ensures that a value is positive. It ensures that a value is positive. Notice, with an even index, when we have an even index, our answer must be what? Answer must be positive. The answer cannot be negative. So how do we ensure that our answer is positive? We use absolute value to ensure that our answer is what? Positive. This is because they chose to ignore what case? They chose to ignore negative case. So for now, I just need you guys to memorize that an even exponent divided by an even index gives an odd result, gets absolute value. So we have an even 8 divided by an even 8 gives an odd number 1. This is absolute value, and this is a difficult thing to understand. I will explain this in its own independent lesson. Now, let's get into today's problems. This was kind of introduced in the videos. All right, so today's problems. First, we're looking at page 443. Okay, so now we start, I guess. Page 443. We're looking at example number 1. Okay, so example number 1. Notice on the last two examples, the exponents divided evenly. So if I wrote the 8th root of x to the 16th, y to the 8th. Do you guys see that 16 divided by 8 and 8 divided by 8 divide evenly? But let's look at this example. Here we have the square root of 36, a, b to the 4th, c to the 5th. If we look at our exponents, question, what is our index? Okay, so we start with our index. What is the unwritten index? If the index is unwritten, the index is a 2. Okay, so what is our index? It's a 2. We're dividing all of our exponents by 2. Question, does 1, what's the exponent of a? The exponent of a is 1, so does 1 divided by 2 divide evenly? No. Does 4 divided by 2 divide evenly? Yes. But does 5 divided by 2 divide evenly? No. So what do we do when the exponents do not divide evenly? We take out groups. And how do we do this? We start by breaking down our numbers. So we're going to start by taking our 36. We're going to take our 36 and break it down. So take your 36 out here, break it down. This is what? We're breaking down to numbers 2, 3, 5, 7, sometimes 11. These are called prime numbers. So we're going to take 36 and make this 2 times what? 2 times 18. 18 is 2 times 9. Break the 9 down. This is what? 3 times 3. And we ask the question, how many 2's multiply to give 36? 2 of them. And how many 3's multiply to give 36? There's 2 of them. So we're going to rewrite this. Instead of 36, we're going to write the square root of how many 2's? Hopefully you say, well, there's 2 2's. So we're going to write this as 2 squared. And how many 3's? There are 2 3's, so we're going to write this as 3 squared. A, b to the 4th, c to the 5th. And instead of dividing our exponents, since 5 divided by 2, remember that our index, the index, if it's unwritten, the index is a 2. So we're dividing by 2. Since the 5 divided by 2 does not divide evenly, we're going to take out groups. Now, if you have not watched the previous videos, I will show this one time. So what do we have here? We have 2 times 2 times 3 times 3 times a times 4 b's, and we have 5 c's. Okay, so we're going to take out groups of what? Groups of, the index is a 2, so we're taking out groups of 2, or we're circling pairs. So circle a pair. Can we circle a pair of 2's? Yes. Remember that every pair comes outside and becomes just 1. So the pair of 2's will come outside and become what? Just 1, 2. Every pair comes out and becomes just 1. So a pair of 3's comes out, becomes what? Becomes a 3. Now what do we do with the 2 and the 3 once we get them on the outside? We multiply them. So 2 times 3 gives what? 6. So I want you to write 6. Now, can we take a pair of A's? No, we just have one A. Can we take a pair of B's? Yes. How many pairs of B? Well, we have a pair of B's gives what? A pair of B's gives a B, and a pair of B's gives a B. And what do we do with the B's? We multiply them together. B times B is what? B squared. Remember that every group comes out, becomes just 1. So a group of 2 B's comes out, becomes 1 B. A group of 2 B's comes out, becomes 1 B. We multiply them together, we get B squared. Now, is there a faster way to do this? Yes. My question is, what is 4 divided by the index 2? What is 4 divided by 2? Well, 4 divided by 2 is just what? 2. So we can simply divide. This is faster. Okay, so let's look. We have c to the 5th, so we have to learn to do this in our head. How many pairs are there in 5? Hopefully you say, well, there are 2 pairs. Every pair comes out and becomes what? Every pair comes out becomes a c. So we have 2 c's and 2 c's coming out to become a c and a c. We multiply these together, we get c squared. What is the faster way to do this? The fast way to do this is to divide. Remember that this symbol means divide. We're dividing by index. We're dividing by the index 2. So the question is, 5 divided by 2 does not divide evenly. However, go to the next number below 5 that's divisible by 2. What is the next number below 5 that's divisible by 2? Hopefully you say 4 is the next number below 5 that's divisible by 2. So if we take the number 4, which is the smallest, and the next number below 5, 4 divided by 2 gives what? 2. 4 divided by 2 gives 2, and how many are left over? We took out 4 c's. How many c's are left over? There's only 1. So we have left under the root, we have what? No extra 2's. We took all the 2's out. No extra 3's. We took all the 3's out. Are there any extra A's? Yes, there's 1 extra A. We took out all the B's. There were 4. We took out 2 groups. We took out 2 groups of 2C. Okay, so if we took out 2 groups of 2C, that's a total of how many? We took out 2 C's, that's 4 that we took out. How many C's were left? There's 1 C left. So we have 1 C left, and our answer is 6B squared C squared root of what? AC. Now the last thing we ask, did we have even divided by even? So we look. Even divided by what? Even divided by even gave what? Odd. Here we go. Even divided by even gave what? Odd. We're looking for even divided by even gives odd, results in absolute value. So we put what around the 2? We put absolute value around the 2. Even divided by even, 2 divided by 2 gives an odd 1. So do we put absolute value around the 3? Well, yes and no. Not necessarily. Positive. Okay, so the absolute value is to guarantee that an answer is positive. However, we have a positive 2 and a positive 3 already. Do we need to guarantee 2 times 3? Do we need to guarantee that the outputs are positive? No, okay, because 2 and 3 we can already see are positive numbers. When do we use absolute value? We use absolute value only around variables. So you will use absolute value only around A, B, or C. Or you will use absolute value around variable terms X, Y, and Z. Okay, so don't use absolute value around your numbers, just your variables. So we're looking for even divided by even. So we have an even 4 divided by what? An even 2. Even divided by even gives odd is what we're looking for. 4 divided by 2 gives what? This gives an even number 2. So this is no absolute value. We're looking for even divided by even gives odd. Now, are we worried about absolute value case on the odd exponents 5 and 1? No. We're looking for even divided by even. So no absolute value here. No absolute value. Our final answer is this. Now, the faster way to do it is just simply do this in your head. You have 2 squared times 3 squared times A, B to the 4th, C to the 5th. We're asking, taking out groups of what? Groups of 2. So we're going to take a pair of 2's out. You see that we have 2 2's. How many groups? Since we have 2 2's and we're taking out groups of 2, how many groups can we take out? We can take out 1 group. So we have 1 2. Is there need for absolute value around our constants? No. We have a pair of 3's. Can we take out 1 pair of 3's? Yes. So we will have 1 3. Again, we multiply these together. 2 times 3 gives what? 2 times 3 gives 6. Can we take a pair of A's? No, because we only have 1 A. Can we take a pair of B's? Yes. How many pairs? Well, there's 4 B's. That is a total of 2 pairs. A fast way to do this is just simply divide. What is 4 divided by 2? The index is 2. 4 divided by 2 is 2. We get what? B squared, representing 2 groups. We have 5 C's. Okay, what's the next number below 5? If you're taking out groups, you can first ask yourself the question, how many groups of 2 are there in 5? Hopefully you can say 2. But the fast way to do this is to go to the next number below 5, which is 4. Okay, the next number below 5 that's divisible by 2 is 4. 4 divided by 2 gives what? 2. So we get C squared. And what's left under the root? Well, we took out 2 2's, so there's no more 2's. We took out 2 3's, there are no more 3's. We didn't take out any A's, so we have an extra A. We took out 2 pairs of B, which is a total of 4. So there are no B's left. We took out a total of 2 pairs of C, which is a total of 4 C's came out. There's 1 C left. And there you go. So, again, thinking the question is better. I'm diagramming this one time, then we're just going to move on. Now, all right, so let's practice another one. Let's practice number 19. This should go quickly now. Taking out our groups. Oh, this is a long lesson. Trying to shorten, I'm trying to move, but it's without explaining, it can get confusing. So square root of 9, a to the 15th, b to the 3rd. Now, first question, are we worried about absolute value here? Well, the first thing you should notice, what is our index? Our index is a 2, so we have an even index. When are we worried about absolute value? We're worried about absolute value on what? Even index, 2, 4, 6. Do we worry about absolute value with even index 2, 4, 6? Yes. This is possible absolute value. However, what about cubed root, 5th root, and 7th root? Do we worry about absolute value with an odd index 3, 5, or 7? No. So no absolute value here. No absolute value on an odd index. However, could we have absolute value on an even index? Absolutely yes. Okay, so you're worried about absolute value anytime you have even index. So is absolute value a possibility here? Yes, because the index is an unwritten 2. However, notice that we're looking for even divided by even gives odd. And we're only looking at variables. So we're looking at our A and our B. Is the exponent of A even or odd? Well, it's odd, so this is no absolute value. So we're not worried about absolute value on an odd or an odd exponent. So no absolute value in this problem because our exponents are odd. We're looking for even divided by even gives an odd. Now, We start the problem always by breaking down our 9. So take the 9, break it down. This is what? 3 times 3. We're going to rewrite the problem as what? 3 squared, a to the 15th, b to the 3rd. And we are taking out what? Taking out groups of 2. So taking out pairs. Remember that our index is an even 2. Taking out groups of 2. Can we take a pair of 3s? Yes. How many pairs can we take? Well, hopefully you say there's 2 3s, so we can only take 1 pair. And every pair comes out becomes 1 on the outside. So every group comes out becomes 1. So since we have a pair of 3s, we're going to have 1 3 on the outside. Now we have 15 A's. Can we take out pairs? Yes. How many pairs of A are there in 15? Hopefully you say 7. How did you figure this out? You go to the next number below 15. And what is the next number below 15 that is divisible by 2? The next number below 15 that's divisible by 2 is 14. And 14 divided by 2 is what? 7. So we get 7 groups. So A to the 7. Now, we have 3 B's. Now if you think 3 B's, how many groups of 2 or how many pairs are there in 3? Well, we have 1 pair of B's. If this pair of B's comes out, we have what? 1 B. And what's left under the root? Okay, so we look at what's left over. We took out 2 3's. Are there any left? No. We took out 7 groups of A. 7 groups, if there were 2 in each group, that's a total of 14 A's that came out. How many A's are left? Well, you had 15 to begin with, so there's only 1 A left. You took out 2 B's. There were 3 total. How many are left? There's 1 B left. And this is our final answer. Now, I think I'll probably just do groups on this video and create a new video for the next set, so this video doesn't go too long. Number 45, because this video is actually taking longer than I expected. Number 45 and page 440, we're on page 444. Number 45 says the cubed root of 16 y to the 4th z to the 12th. Now, are we worried about absolute value on this problem? Are we worried about absolute value? No. Remember that if your index is odd, we have no problems here with absolute value. So let's go ahead and start by taking our number 16, breaking it down. 16 is 2 times 8, which is what? 2 times 4, which is 2 times 2. How many 2's multiply to give 16? Hopefully you say there are 4 2's that multiply to give 16. So we're going to write this as what? The cubed root of 2 to the 4th, y to the 4th, z to the 12th. And what are we taking out? We're taking out groups of 3. So now the question is, can we take a group of 3 2's? Yes. We have 4 total. If we take a group of 3 2's out, how many groups is that? Or I should say, how many groups of 3 2's are there in 4? There's only 1 group. If I write it out, 1, 2, 3, there's 4 2's. We take a group of 3 2's out, it becomes just what? Just a 2. Now, we have 4 y's. How many groups of 3 can we take out? Hopefully you say just 1. Okay, so we take out 1 group of 3 y's. We have a y on the outside. We have a total of 12 z's. How many groups of 3 are there in 12? Do you see that groups of 3 is the same as dividing? So this is the same as taking 12 and dividing by 3. How many groups of 3 are there in 12? Well, you can simply take 12, divide by 3, and get what? 4. If I write 12 z's, one more time. Okay, so dividing by 3 is the same as circling groups of 3. So circle a group of 3, circle a group of 3, circle a group of 3, circle a group of 3. And how many groups are there? There are 4. The number of groups, if I write 12 divided by 3 equals 4, 12 is the total number, 3 is what you circle in each group, and 4 is the number of groups. Okay, so we have 4 groups. So you can ask, if I ask how many groups are there in 12, I'm asking you to take 12 and divide by 3. 12 divided by 3 gives what? 4. So this again means division of the exponent. 12 divided by 3 gives 4, so we get z to the 4th. And now we're asking what's left under the cubed root. So don't forget to leave what remains. We took out a total of 3 2's. How many 2's are left? Hopefully you say there's 1 2 left. We took out a total of 3 y's, so how many y's are left? Hopefully you say 1 y is left. We took out a total of how many z's? Well, we took 4 groups of 3, which is a total of 12 that came out. Are there any z's left? No. So we're done with this. Okay, next.